Today we are going to integrate e raised to the x cos x dx using integration by parts. For simplicity, let I be equal to the integral of e raised to the x cos x dx, right? Now recall that the integral of u dv by dx is equal to uv minus the integral of v du by dx. Now we need to find u dv by dx, du by dx, and v. Now we have two functions, e raised to the x and cos x. I am going to arbitrarily choose u to be equal to cos x and dv by dx equal to ex. Therefore, du by dx is equal to minus sine x and v is equal to e raised to the x. That is integrating both sides here. Now I, which is equal to the integral of e raised to the x cos x dx, is equal to u, which is cos x, v, which is equal to e raised to the x, minus the integral of v, which is e raised to the x, du by dx, which is equal to minus sine x dx. Simplifying, let me rearrange also. E raised to the x cos x minus, well, this becomes plus because it's two minus here, the integral of e raised to the x sine x dx. Now we end up with another problem. We need to find the integral of this bit here. So this becomes the integral of e raised to the x sine x dx. Right, we're going to use integration by parts again. And now we have u dv by dx, du by dx, and v. Here we need to be very careful, because whatever we chose, the type of function we chose for u up here, we need to choose the same type of function down here. So in the above we let u equal to a trig function. Now u must also be equal to the same trig function down here, which is sine x dv by dx is equal to e raised to the x. So we are not going to change our order of how we let our substitution be. So if we had up the top, if we had let u be equal to e raised to the x, down here u must also be equal to e raised to the x, and so forth. Now du by dx is equal to cos x, dv by v is equal to e raised to the x. Now the integral of e raised to the x sine x dx is equal to u, which is sine x, v, which is equal to e raised to the x, that's v, minus the integral of v, which is equal to e raised to the x, and du by dx, which is equal to cos x dx. Rearranging, e raised to the x sine x minus the integral of e raised to the x cos x dx. If we look carefully here, we see that this is what we chose to be sorry. Therefore, this is equal to e raised to the x sine x minus I. This is our original question. So I up here becomes e raised to the x cos x plus e raised to the x sine x minus I. Now let me create some space. In is equal to e raised to the x cos x plus e raised to the x sine x minus I. Sorry about the notation here. This is I, not in. Now we can see that we have I on both sides. So if I add adding I to both sides yield e raised to the x cos x plus e raised to the x sine x minus I plus I. This cancel, we are left with 2I is equal to e raised to the x cos x plus e raised to the x sine x. So solving for I yield I is equal to e raised to the x cos x plus e raised to the x sine x over 2. So I, which is equal to the integral of e raised to the x cos x dx, is equal to, I'm just going to let this look a bit mathematically simplified. So this becomes e raised to the x over 2 times cos x plus sine x plus c. This is our constant of integration. We must have it in. So this is our solution. Note that we had to integrate 2 times by parts to eventually solve this problem. And bear in mind, whichever type of function which we chose for u, we need to continue with that same type of function. So in the top, before we chose u to be equal to cos x, the second subset integration by parts, we chose u to be equal to sine x. So these are the same type of function. They are trig functions. So bear in mind the consistency as well. So here we have our solution. Thank you for watching. I'll see you in the next class.